In this video, I am going to introduce you to some special trigonometric limits. So, our first limit is limit x tends to 0, sine x over x is equal to 1. And our second special trigonometric limit is limit x tends to 0, 1 minus cosine x over x is equal to 0, right? And my third trigonometric limit is limit x tends to 0, tangent x over x is equal to 1, right? Now let's consider an example. So my example is find the limit x tends to 0, sine 4x over x, right? So as you can see, my limit is given right here and we need to find the limit. So if you look at the limit, my function is sine 4x, right? I have x at the denominator. Now, in order to solve this question, let's consider this formula. And if you look at the formula, my formula is sine x over x. So, whatever I have for the angle, I have exactly the same term at the denominator. But over here, I have 4x, but I have only x over here. So, how do I make this 4x? So, one way I can do, I can multiply numerator and denominator by 4, right? So, if I multiply numerator and denominator, my limit will be limit x tends to 0. I have sine 4x, right, over x times 4 is 4x, right? And then I have 4 left, which is basically what? This 4 right here. The one that I have at the numerator. Now, if I apply the limit, this will be my what? Limit x tends to 0, sine 4x over 4 is what? 1, because I'm using this special trigonometric limit. So, this will be 1 times 4, and that is equal to 1 times 4 is 4, right? Now let's consider another example. So my example is find the limit x tends to 0, x over tangent kx, right? And only way I can use this formula if I have the same term over here. So what I'm going to do, I'm going to multiply numerator and denominator by k. So this k will go with x, and I will write this is equal to limit x tends to 0, k times x is kx over tangent kx, and this k from the denominator, this k can go up front and I can write 1 over k, because this k is at the denominator, which is basically what? 1 over k. Now, let's simplify further, and if I do that, I will write 1 over k limit x tends to 0, and I can write this one as 1 over tangent of kx over kx, right? Because if I flip the denominator, I will get exactly this term right here, right? Now I can apply the limit, and if I apply the limit, I will write 1 over k, and I have 1 over, I'm going to apply the limit x tends to 0, tangent kx over kx. And we know that from this formula, that tangent x over x is 1, so tangent kx over kx will be 1 for limit x tends to 0. So I can write this one as, this is equal to 1 over k from here times 1 over this whole thing that I have is what? 1. So 1 over 1, and 1 over 1 is 1, so 1 over k is basically what? My final limit for this expression. So the limit of this function is basically 1 over k, right? And this is how we will use the special trigonometric limits to find the limit of given trigonometric function.